Okay, class. So the other day with the Discord, wasn't really able to show you weight conversions and units of measurement the way I wanted to due to some of the technical difficulties with using my laptop and my finger to write. So we're going to do that one more time right here on the Promethean board. So I hope it's a little more clear for you. First thing I want to start with is weight conversions. Now, the way to figure out how to go from pounds to kilograms is to divide by 2.2. So you can use a calculator to do that. In not all cases will you have a calculator. So there is a shortcut you can use, which is where you will divide by 2 and subtract 10%, right? So let's do a couple examples here. So say I have a patient that weighs 80 pounds. First step is to divide by 2, and that's going to give me 40, right? Now I need to determine what 10% of 40 is. The way that I can do that is by moving my decimal place one place to the left. That's 10%. So if my decimal place is here, move it one place to the left. I'm now going to subtract 4 from 40. That should give me an answer of 36 kilograms. Let's do one more example. Say I have a 150-pound patient. First step here is to divide by 2. That should give me 75. Right. Once I've divided by 2, I need to determine what 10% of 75 is by moving the decimal place one place to the left. So I will subtract 7.5 from 75, and that should give me 67.5 kilograms. Right? One more, just for good measure. 40-pound patient. So 40-pound patient, this is going to be about the size of a toddler. So my 4-year-old weighs about 40 pounds. So we would use this for pediatric patients as well as adult, and that's most likely like a young small adult or school age child, patient. 40 divided by 2 is going to give me 20. Subtract 10%. As we just learned, 10% of 20 is going to be 2, simply by moving the decimal place, minus 2. My patient here is going to be 18 kilograms, and that's what I would use as my conversion weight. Now, when you do the math in the calculator and divide by 2.2, your answer is going to be slightly different than this, but this shortcut will definitely get you within 1 or 2 kilograms of what the actual conversion is. And this definitely works for quick conversions in the field to be able to calculate our medication dose. Let's move on to the next one. Say we needed to go from kilograms to pounds. Now, this one's not as common because most, if not all, of our medications that are weight-based go off the patient's weight in kilograms because we use the metric system in medicine. But there may be times where you need to know how much the patient weighs in pounds from kilograms. The way to do that, or the shortcut to do that, is to multiply by 2 and then add 10%. So the way that we would do that, if we have a 70-pound patient, we would do 70 times 2, which is going to be 140. Right? Same thing here to determine what 10% of 140 is. You simply move the decimal place one position to the left. So then you're going to end up adding 14 to this. So 140 plus 14 is going to be 154 pounds. 154 pounds. So we do another one. Say we have a patient that's 110 kilograms. We do 110 times 2. That should give us 220. 220. 10% of 220 is going to be 22, simply by moving the decimal place one place. So we're going to add 22 to that. And we add these two together, we should get 242 pounds. Last example, we have an 8-kilogram patient. So this is most likely going to be a young child, possibly an infant. 8 times 2 is going to give me 16. 10% of 16 is 1.6. I'm going to add 10%. 16 plus 1.6 gives me 17.6 pounds. And that's how I would do my conversions. Now, if you do come out with an answer that has a decimal place, make the math easy for you. You don't have to use the 17.6. If it's 5 or greater, just go ahead and round up. And we would say that this patient is 18 pounds. And that's what we would use to determine what our medication dose is. Next, I want to look at unit conversions. Now, for medication math, really the only three mass units of measurement that we use are grams, milligrams, and micrograms. Kilograms is out here, but it's a large unit measurement. You typically don't see medications packaged in kilograms. That's how we weigh somebody. Because these unit measurements are separated by dividing or multiplying by 1,000, that allows us to very simply just need to move the decimal place either to the right or to the left to convert back and forth between the different units of measurements. So say, for example, we had a medication that's packaged in grams, and I needed to know how many milligrams are in that amount of grams. All I would need to do is find where my decimal place is and move it 1, 2, 3 places to the right, and that's moving it a thousandths, and that will give me my answer. And then same thing, if I had a drug that's in milligrams and I need to go to micrograms, I move the decimal place 3 places to the right. All right. It also works vice versa. Right. Say that I have a medication that's packaged in micrograms and I need to know how many milligrams it is. All I need to do is move my decimal place 3 places to the left, and I get my answer. So just by moving the decimal place to the right or to the left, you should be able to very quickly figure out these unit conversions. So let's look at some examples. Say I have 2 grams and I need to convert it to milligrams. Well, I'm going to write it here so we can see it. My decimal place is right here. Now I need to move my decimal place 3 places to the right because I'm going from grams to milligrams. So 1, 2, 3, fill in with zeros. My answer is going to be 2,000 milligrams. Perfect. Keep going here. The next one, I have 750 milligrams and I need to go to micrograms. So this is kind of the same example as this one, except I'm going from milligrams to micrograms. So again, I'm going to move my decimal place 3 places to the right. So if I have 750, decimal place is right here. 1, 2, 3. New decimal place, fill in the zeros. I have 750,000 micrograms is 750 milligrams. We'll come back to this one. So let's go to this one. So now I have a medication that's in micrograms, and then you go from micrograms to milligrams. So how would I do that? Well, I'm going to take my decimal place that's right here, and I'm going to move it 3 places. 1, 2, 3, fill in the zero. So my answer is 0.12 milligrams. In this case, I had to move the decimal place to the left because I'm going from a smaller unit of measurement to a larger unit of measurement. Now look here. This is going to be a really large number because I'm going from milligrams to micrograms, but I have a lot of milligrams, right? 6,500 milligrams is quite a bit. So my decimal place is right here. I'm going to rewrite it. Decimal place is here. I'm going to move it 3 places to the right. 1, 2, 3. Fill in. I'm going to have 6,500,000 micrograms in that example. And then the last one that I'm going to show you is I need to go from grams to micrograms. Well, when I look at this, I know that it's 3 places to the left to go to milligrams and another 3 places to go to micrograms. So I'm going to need to move my decimal place a total of 6 places to the right to do this unit conversion. So if I write it here, 1, 2, 3, 4, 5, 6, fill in my zeros, I'm left with an answer of 250,000 micrograms. This is going to be essential because sometimes you're going to have medications that aren't, the desired dose isn't the way that it comes packaged. So for example, say that you have a bag here that you're trying to give to somebody, and inside this bag you have 4 milligrams of a drug and 250 milliliters. Right? But the desired dose that you intend to give is 5 micrograms per minute. When it comes time to actually do our math formula, when we learn that, you have to be able to convert this milligrams into micrograms so these units of measurement match. If you forget this step, you won't get the right answer. Next thing I want to show you again is the concentration shortcut. Now, medication concentrations are packaged in mass and volume, right? So for example, say that we have a medication that I have 0.1 milligrams in 10 milliliters. Now, This is the same thing as if I was to take a drink packet that has 25 grams of a drink packet and I was to dump that into 250 milliliters of water, like a water bottle, right? That 25 grams doesn't go away, it just mixes in with the water. This is the same thing here. The mass of the medication is mixed in with the volume or the solution that is suspended within. Now, a critical step with any medication math problem is being able to reduce this medication concentration down the amount of medication that is in 1 milliliter, right? 1 milliliter. That one right there, we don't have to write. It is just invisible there. We just know it's there. Well, the shortcut method that we can use takes out all of the math or the long division we would have to do. If I was to do this manually, I would have to do long division for 0.1 divided by 10. You absolutely could use a calculator and get that answer really quickly also. Now, with this, say that or for this shortcut method, we have to get the denominator to be a factor of 10, 100, or 1000, right? So without this denominator being 10, 100, or 1000, the shortcut method that I'm going to show you will not work. So if we look at this one, I can already tell that, hey, 10 milliliters, that's already where I need it to be. So in this case, all I need to do is simply move my decimal place one place, right? So I'm going to move it one place to the left. That's going to get me to the one that I need right there. Once you do the one side, you have to do the other side. So I'm going to move the decimal place one place in the same direction, and I'm going to get 0.01 milligrams. So that means for every milliliter, it's going to have 0.01 milligrams of medication in that solution. Let's look at another example. Say that I put 1 milligram of epinephrine into a 500 milliliter bag of fluid, right? Because I want to give somebody a epinephrine infusion, right? Their blood pressure is too low, and I want to try to bring it up by giving them a vasopressor in this case. Now, when I do my medication math, I have to know how much of epinephrine is in 1 milliliter, so I can use my factor method. Now, if you look, 500 is not 10, 100, or 1,000. So if your number here is not 10, 100, or 1,000, it has to be a multiple of one of those. So I know that 500 times 2, so 500 times a factor of 2 is going to get me to 1,000. So no, that's going to get me to 1,000. When I do to one side, I have to do to the other side. So 1 times 2. 1 times 2 is going to give me 2. Okay. So now I'm set up here. It's as easy as moving the decimal place. In this case, the decimal needs to be moved 3 places to the left. 1, 2, 3. And I can write milliliters, which is what I want to be. And then same thing here. I'm going to move the decimal place 3 places to the left. 1, 2, 3. Fill in my zeros. And I'm going to have 0.002 milligrams per milliliter. Now, one catch to this, because this is an epinephrine infusion, my desired dose is actually in micrograms. So I need to convert this milligrams per milliliter to micrograms by moving the decimal place 3 places back to the right, and I'm going to get an answer of 2 micrograms per milliliter, right? So this method will work that way to be able to convert back and forth. Now, because I know that this step right here is just going to simply convert it back to what I got here. You see how this is the same as this, right? Just different concentrations. The shortcut has kind of an extra shortcut to it if you want to think about it that way. So say in this example, we're doing a norepinephrine infusion. And I have 4 milligrams, and I put that 4 milligrams of norepinephrine into a 250 milliliter bag of IV fluid. Also, I don't know if I've told you guys yet, milliliters and cc's or cubic centimeters, they equal the same thing. So if you see cc, that's another way of saying milliliter. Okay. So first step is I need to know what my factor is. So 250 is going to multiply by 4 to give me 1,000. So I have a factor of 4. When I do the one side, I do the other side. 4 times 4 is 16. 16. And I know by 250 times 4 is 1,000. I'm just going to move the decimal place anyway, so I'm just going to go ahead and write milliliter. and just not skip that step, but do it in my head real quick and not write it, right? And then now that I'm here, because I know that I'm going to convert it and then have to move it back again, all I need to do is drop it one mass unit. So I'm going to go milligrams, and I'm just going to get changed to micrograms. So 4 milligrams in 250 milliliters is, for every milliliter, there's 16 micrograms. This step is critical when trying to figure out how many drops per minute to give a patient, because your medication math formula requires you to put in the concentration. And if you leave it like this, you won't be able to get the right answer. No matter how hard you try, a calculator can't even give you the right answer if you forget this very simple step right here. Okay. I hope that's making a little bit more sense. A couple other things with medication math that I like to go over is one that, med math skills are perishable. It's one of our perishable skills. And it's also one that we don't train as much as we would train something like innovations or IVs, IOs like we do in class. So make sure that you're practicing med math on a routine basis, looking at how medications are concentrated, looking at your drug dosage, and just working some of these real world problems out. Um, During your studies, so that when it does come time to give a patient a medication in the field, you're able to get through the medication math without getting bogged down or kind of hitting a wall. Using calculators. I'm absolutely okay with you using calculators while you're learning, but please be aware that when it comes time for the medication math exam, there will be no calculators. So my advice is use the calculator to help you get through and understand the underlying process, and then start to remove the calculator from your studies, so that you can do it without the calculator. That's the best way that I've found to learn medication math, because it allows you to focus first on understanding what the shortcuts are, what the formulas are, how to plug things in, and how to get the right answer. And then you remove the calculator, and then you focus on how to do the long division or the long multiplication. All right. I hope this helped. We'll see you in class.